So in life, everybody makes mistakes. So the first part of correcting your mistake is admitting that you made one. So yesterday, I made a mistake on our notes. So at the very top, we need to switch converge and diverge. Okay. Thank you, Cassidy, for the whiteout. That is wonderfully working very well right now. Okay, so at the top, if R is greater than 1, then it's diverge. And if it's less than 1, it converges. Okay. So I switched those. So greater than 1, diverge, less than 1, converge. Sorry, next semester. About that. Okay, so yesterday we talked about a finite geometric series which had a certain number of terms. So today we're looking at an infinite geometric series, which means it goes on forever. So an infinite geometric series never ends. Okay. So it goes on forever. It has an infinity amount of terms. Okay. So same thing that we did yesterday. Let's say we want to find the sum. And let's say our first one is 1, 1/2, 1/4, etc. Okay. So it doesn't give me an end. I don't know where to stop because I want to find the sum of the entire thing, but it goes on forever. So let's just pick some n's. So let's say we want to find when n is 25, when n is 50, and when n is 500. And so in our formula from yesterday, we still need 3 things. We need an n, which it tells us. We also need a1, and we also need r. So what is my a1? 1. Good. What is my r? What's it multiplied by each time? Good. 1/2. So then for this first one, n equals 25, we want the sum of the first 25 terms. And our formula is a1, which is 1, times 1 minus r, which is 1/2, to the 25th, over 1 minus 1/2. Now when you're typing in the calculator, if you want to use 0.5 instead of 1/2, that's fine. It doesn't matter. It gives you the same answer either way. So then we can just type it in. And so if you type it in the fraction, that works great. If you don't, remember you have to put that bottom part in parentheses. And so hopefully you get 1.9999999. No. Not yet. Well, now we want to find when n is 50. Same exact formula. What's the only thing that changes? Yeah, the exponent. So now instead of 25, I want 50. If you don't want to type all that in again, you can just hit second enter, and then you can just go up here to the 25 and make it into a 50. And that's the easiest way to do it. Then you don't have to type it all back in. And then we hit enter. And we get 2. So the sum of the first 50 terms is 2. So then we want to do 500. Again, we can just hit second enter. Instead of 50, we type 500. And we hit enter. And we get 2 as well. So the sum of the first 500 terms is 2. Any ideas as to why it's not changing? Perfect. Yes. Good, good, good. So in this one, our numbers are getting smaller and smaller and smaller and smaller and smaller. So eventually, like if I just do 1/2 to the 500th power, my calculator assumes it's 0. It's not 0. But it's so close that you might as well call it 0. So when we keep on going with these n's, somewhere between 25 and 50, they just get so small that they don't change that total amount. Okay? So then we can say the sum of this is 2. So the sum is 2. Okay. You could also say it converges to 2. And so, like we just fixed a second ago, our r was 1/2, which is less than 1. So if it's less than 1, it's converging. So they're going to get closer and closer and closer to a number. In this one, that number is 2. Let's look at another one. Let's say we've got 1, 2, 4, etc. So again, we just want to find the sum. It doesn't give us any n, so let's pick the same ones. Let's find when n is 25, when it's 50, and when it's 500. So we still need the same 3 things. We have the n, but we need a1 and we need r. So what's our a1? 1. What's our r? What are we multiplying by? 2. Good. So then for our first one, the sum of the first 25 terms, again, our formula from yesterday is 1 minus 2 to the 25th over 1 minus 2. And then again, we just type it in. If I can ever type it in. So we type it in, and hopefully you get this big, huge number. So 3, 3, 5, 5, 4, 4, 3, 1. Okay. So now we want the sum of the first 50 terms. Again, everything's still the same except for our exponent. So instead of 25, let's do 50. So again, you can hit second enter and just change that 25 to a 50. And in this one we get this. So when you get that e to the 15th, remember that's your scientific notation. So that means I want to move my decimal 15 places, since it's positive, to the right. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the rest of them need to be zeros. So 1, 1, 2, 5, 8, 9, 9, 9, 0, 7, that's 9, 10, 11, 12, 13, 14, 15. So we need to add 6 zeros to it. So what would that be, like 112 zillion? Okay, so now let's do the same for 500. So again, we're just taking our 50, changing it to 500. And what do you get on that one? Overflow. So that means this number is so big that our calculator can't even tell us what it is. Yeah. You can, yeah. So pretty much what we're saying here is that we're going to infinity. Okay. Now, we can never reach infinity. Our answer can't be infinity. So in this one, we would say that it diverges. Okay. So it's getting big and big and big and big and big. It's never stopping. It's just going forever. And so the sum does not exist. So you can look at a series and know if it's going to converge or diverge based on the r value. So if r is greater than 1, so in this one it's 2, they're just going to get getting bigger and bigger and bigger, so that's divergent. So then the sum doesn't exist. But if it's less than 1, like in our first one, it's going to converge to a number. So what you can do is, you can use the formula that we did yesterday. You just have to find your own n value. Or you can use this function, or formula. So for an infinite series, only if it's converging. If it's diverging, it doesn't exist. Okay? But if it's converging, you can use S of n equals a1 over 1 minus r. Okay. So if you remember the formulas I showed you the day before yesterday, the geometric had 2 formulas. So it gives you the one we did yesterday. It also gives you this one. Okay. And so again, you only use this if it's converging. If it's diverging, if you're greater than 1, it just doesn't exist. Okay. But if you look at the one from yesterday, the whole 1 minus r to the n, that just, like I said, gets so small that pretty much you're doing 1 minus 0, which is just 1, and a1 times 1 is a1. So that's why that part goes away. So like if we tried this one for our first one, our a1 was 1, and then 1 minus 1/2 gives us 2. Okay. Which is what we got for this one, it converged to 2. So whether you use the formula from yesterday, whether you use this one, doesn't matter, you get the same answer. The only thing is if you use the one from yesterday, you have to make up your own n value. So, but you could always do like 100 and that would work. So then the last thing we're going to talk about today is sigma notation. And so sigma notation is just another way to write that you want to find the sum. I don't know if it'll be on your final exam, but it's super easy. So I thought, well, might as well show it to you either way. So it looks like this. And that's a sigma, or a summation notation, is what it's also called. And so what it's going to have is it's going to have an n, a big N, And then it's going to say n equals a number. It can be 1. It doesn't have to be 1 though. And then it's going to have an equation. An explicit formula, to be more exact. So the big N tells you the number of terms. So if it's 5, you want to find the sum of the first 5 terms. So the big N is kind of like what we've been doing with our little n. And then the n equals 1, or n equals whatever that number is, that tells you which term to start with. So the number on top tells you how many terms you're finding the sum for. The number on the bottom tells you which one that you want to start with. So let's do one. So let's say we want to do the sum of 4 terms. We want to start with the first one, and we want the sum of 1 minus 2n. That's a terrible looking sigma compared to my first one. Okay, so we want to find the sum of the first 4 terms. We're starting with the first term. So we need to find A1, A2, A3, and A4. How can I do that? If I know this right here is my explicit formula, yeah. So we just plug in 1, 2, 3, and 4. So 1 minus 2 times 1. 1 minus 2 times 2. 1 minus 2 times 3. And 1 minus 2 times 4. Good, so what's my first term? -1, good. What's my second term? -3, good. How about my third term? And fourth term? Good. So if I want to find the sum of these, what should I do? Add them all up. So then we get that the sum is -16. Questions? So for this one, that's not that bad. We just wanted 4 terms. But what if we want the sum of 50 terms or the sum of 100 terms? I don't want to list them all out. But we don't have to because we have our best friend, TI-84 Plus. And he can do this for us. So let's do it. So what you want to do is you want to go to Math. And you want to go to the bottom. And we want number 0. It says summation. And it's got the little sigma. Okay. So you have to pick your own number. You can use N if you want to. I always just use X because X has its own button. But it doesn't matter. Whatever letter you want to use. And then you just type it in just like it looks. So X equals 1. Up top, we had a 4. Now, the only thing is, whatever's in your summation, all of that has to go in these parentheses that it gives you. So 1 minus 2x. Okay, so the whole equation goes in those parentheses. And hopefully we get -16. And we do. Questions?
So, instead of doing anything different, you just get on the calculator?
Yeah. Nope, you just do it. Let's type one more, and let's look at a geometric one, and then we'll be done. So, let's say we want to find the sum. First 10 terms. Start with the first term of -4 times -2 to the n minus 1. If you have an older calculator, there is a way to still do this on there. We'll have to tell you later, so I don't remember. So to type it in, we go math. We go to 0. Again, you can pick whatever letter you want to. I'm going to use x equals 1. We want the first 10 terms. And then everything, -4, -2, n minus 1, all that goes in these parentheses. Okay. And hopefully you get 1364. Any questions? You may not get that.